Hello, this is my science fair project Green Remediation. Can aquatic plants perform phytoremediation to decontaminate heavy metal polluted water? This study was designed to use cheap and frequently available materials to remove lead from industrial wastewater by using bioassays and phytoremediation. This is important because industrial wastewater is used for agriculture in many countries without much treatment, which reduces plant growth and health. The continued decline in plant growth reduces yield, eventually leading to food insecurity. Therefore, the remediation of heavy metal polluted soils cannot be overemphasized. The purpose of the study is to find out how long it takes duckweed to remove heavy metal from polluted water, if the same amount of duckweed is enough for the different concentrations, and if not, what is the best amount of duckweed in each lead concentration that efficiently helps early seedling growth. This project was accomplished through 3 experiments. The first experiment was with 5 petri dishes that have 5 green gram seeds in each dish. Next, 150 of the 10 ppm concentration was taken and 30 ml of it was placed in 5 containers. Afterwards, put 1 gram of duckweed in each container. This experiment kept the duckweed in containers for different amounts of time. For example, in the first container of duckweed only remained in there for 1 day, the second container for 2 days, etc. After that, the water was used to irrigate 1 set of seeds, 3 ml of each day, for the next 7 days. The morphological parameters were recorded and analyzed. Using this data, it was found that which day onwards the seeds are showing improvement in morphological parameters. The second experiment used 5 petri dishes with 5 seeds in each dish. It also used different concentrations of lead, 10 through 50 ppm, and put the same amount, or 1 gram, of duckweed in those, and used water 3 ml, the next set of petri dishes with seeds, and check the seeds' growth. Record morphological parameters and analyze them to find whether the same amount of duckweed is enough for different lead concentrations. The third experiment used 30 ml of different lead concentrations, 5 sets of 5 petri dishes, 10 to 50 ppm. The duckweed was added to the lead concentrations in different amounts from 0.5 to 3.5 grams. Then this will be irrigated to the seeds in 3 ml for the next 7 days. The root length, shoot length, and number of seeds with emerged leaves and germination rate were noted and morphological parameters are analyzed. By putting more duckweed plants in the concentration, it absorbs more lead from the water. The effect of various parameters such as vigor index, tolerance index, and percentage of phytotoxicity were studied and good results were obtained while using different amounts of duckweed plants to filter lead from contaminated water. However, improvement in seedling growth beyond an optimum or perfect dose got slower. The perfect dose found in this experiment was 10 ppm for 1 gram of duckweed, 20 ppm 1.5, 32, and then 40 to 2.5, and 53 grams. The results showed that duckweed needs 4 days to effectively remove lead from polluted water, and when put same amount of duckweed in different lead concentrations, the root length, shoot length, and number of seeds with emerged leaves got worse as the concentration of lead increased, which indicates that lead badly affects seed growth and can use the exact amount of duckweed plant for removal of heavy metals on a large scale and create effective, cheap, and efficient methods in treating wastewater. The contaminated duckweed can be possibly useful for generating bioenergy or biochar by pyrolysis, as it is resistant to decomposition, so the heavy metals will be locked in there for almost 100 years, and at the same time will generate a renewable source of energy as well. Thank you.